Factoring is an extremely valuable algebraic operation in the math science option. You're going to use these strategies, these skills, in order to solve problems in the math science option. Also, factoring is an important skill if you're going to continue your math studies, such as for trigonometry and for calculus. So in this particular voice thread, we're going to look at, well, what does factoring mean? When do we use factoring? We're going to look at the very first method of factoring that you learned in secondary 3, and that is the greatest common factor. And we're going to look at several examples. So this is the first voice thread in a series of 5 voice threads that cover factoring that you're responsible for knowing in the math science option. For this voice thread, for this lesson, it's important that you know your basic algebraic operations. What do I mean by that? Do you know how to add, subtract, multiply, and divide algebraic expressions? You should already know this in order to be successful in this voice thread. Well, what does factoring mean? Another way of saying factoring is to write as a product. And here's a simple example. If I had the number 10 and I wanted to write as a product, I could write it as 5 times 2. We say that 5 is a factor and 2 is a factor. When do we need to factor? When do we need to write as a product? Here's an example. If I told you that the area of the triangle shown below is 39 centimeters squared, and I asked you the question, what are the dimensions of the rectangle? What would you say? I could say that the base is 3 centimeters and the height of this rectangle is 13 centimeters. Why? Because they told us that the area of the rectangle is 39 centimeters squared. So in order to find the area when I know the dimensions, I multiply 3 times 13, and that gives to me 39 centimeters squared. So factoring is finding the dimensions of a rectangle. That's an example of when we use factoring. Now, of course, you could have said that the base was 1 and the height was 39 because 1 times 39 is equal to 39, but usually we don't use 1 as a factor. So 3 times 13 is equal to 39. 3 is a factor. 13 is a factor of 39. So if you're given an algebraic expression and you need to factor, you need to find the product of that algebraic expression. We have several methods, and I've broken them down into 5 methods. In this voice thread, you're going to learn about finding the greatest common factor. In later voice threads, you're going to learn about the difference of 2 perfect squares, about the grouping method, about what I call easy trinomials, and the decomposition method. The first step is always to recognize what factoring method you're going to use. Here's a mind map that will help you. Always ask yourself the question, is there a GCF? What does GCF mean? Is there a greatest common factor? If there is, then you factor using the GCF method. Always ask yourself, after you've done one factoring method, ask yourself, can you factor any more? If you cannot factor anymore, then your work is done. If there is no GCF, then you ask yourself the question, how many terms? If there are two terms, we'll look at that in a later voice thread. You will use the difference of two perfect squares method. If there are three terms, you will learn in later voice threads that you decide between the easy trinomials and the decomposition method. If there are four terms, you will ask yourself the question, how will I group my terms? And you will learn that in another voice thread. In the tile following this message, you're going to get a link to a document, and it is a memory aid that will help you sort this out. I hope it'll be useful for you. I'm not going to read this slide for you. I would like you to pause this voice thread and read the steps. These are the steps that I will go through in this voice thread in order to factor when you've got to find the greatest common factor. And we abbreviate this method as GCF, greatest common factor. On the following slides, you will get the solutions for these five expressions. So on the board, you see five algebraic expressions, and the instructions are to factor the following. In other words, write as a product. 5x squared plus 5. First method, always verify if there is a greatest common factor. So we look at that and we always verify the numbers first. Notice we have 5 that is a factor in both terms. What happens next once you've recognized what the greatest common factor is, and that's what we call it? We call it the greatest common factor. 5 is a greatest common factor. So you place that number, then you place a set of brackets. The next step is to find out what are you going to multiply 5 by in order to get 5x squared plus 5. Why don't you think about that for a minute, and I'll show you in the next slides. So in order to get what we multiply 5 by, in order to get 5x squared plus 5, we take that greatest common factor and we divide into both terms. Here we've got two terms. This is what I've shown here. So 5x squared plus 5 is your original question. The GCF is 5. In order to get the other factor, I'm going to divide each of those terms by that GCF. Think about what you will get, and I'll show you in the next slide. So when I divide 5, remember 5 is the GCF, into both of those terms, 5x squared divided by 5. The 5's eliminate. 5 divided by 5 is 1. What am I left with? X squared. I'm going to add, then 5 divided by 5 is 1. I'm adding 1. These are the factors. I've just written this expression as a product of factors. Now you can always verify to make sure that you are correct. How do you verify? And this is where your algebraic knowledge comes in. We've got a 5 in front of the bracket. That means I'm going to multiply both terms inside the bracket by 5. So if I'm going to verify, 5 times x squared is 5x squared, and 5 times positive 1 is positive 5. That is indeed my original expression. I've written it as factors. I've written it as a product of two algebraic expressions. Let's go to more examples. First method to verify, is there a GCF? In the previous example, we had a numerical value as the GCF. Sometimes we have algebraic values. Do you notice that we have an algebraic expression that is common in all three terms? What will that greatest common factor be? It's going to be a C. Just like before, I found my GCF. This is my GCF, my greatest common factor. I place my brackets. How do I find what will go inside the bracket? I divide that greatest common factor in all three terms. Why don't you try that? And I'll show you on the next slide. So just like before, if I'm going to find my other factor, I've got to divide the original expression by the GCF. I've got to take each of those terms, C cubed, C squared, and C, and I divide by the GCF. Always divide by this GCF. Do you remember your rules for division when you have algebra? Go to the next slide and we'll take a look at that. I've written as a product of factors. Here's my GCF. In order to get my other factor, I have to use my rules for exponents, for dividing exponents. Remember, you keep that base, it's got to be the same base, C, and you subtract the exponents. Here it's understood that there's a 1. When I subtract the exponents, 3 minus 1 is equal to 2. Therefore, C cubed divided by C is C squared. I'm going to subtract, same idea. C squared divided by C. I keep that base and I subtract the exponents. Here it's understood the exponent is 1. 2 minus 1 is 1. Whenever we have the exponent of 1, we do not need to write it. It's understood that when there's no exponent, the exponent is 1. I'm subtracting. C divided by C is 1. These are my factors. What I've done here is I've written the original expression as a product of algebraic expressions. I can always verify. How do I verify? I've got a C in front of the brackets. In order to verify, I simplify and I multiply C by every term. C times C squared is C cubed. C times negative C is negative C squared. And C times negative 1 is negative C. I've verified my factors are correct. Let's take this up a notch. Factor. We've got to factor this algebraic expression. Always verify if you have a GCF. Always look for numbers first. Numbers that could be common factors in each of the terms. So we look here, we've got 8, we've got 6, we've got 4, 2 will be our greatest common factor. How do we know that? That's because we can divide 2 into each of the terms. We can divide 2 into each of these terms and we get a number. Now, here's something that will be valuable whenever you're factoring. Normally, when the first expression is negative, we say that the GCF is a negative value. So our GCF will be negative 2, just like before. I place my brackets, just like I have here, just like before. What are we going to do next? We're going to find the other factor. How do we get that other factor? We must divide each and every term by the GCF. Take a minute to do that in order to find the other factor. It would be wise not to skip any steps. So you're dividing each of those terms by the GCF. Be careful because you're dividing by a negative number. Remember, a negative divided by a negative is a positive. Therefore, -8 divided by -2 is a positive 4. B cubed. There's no b here, so I've got b cubed. Be careful. A negative divided by a negative is a positive. 6b divided by 2. 6 divided by 2 is 3, and I don't have any b's in the denominator, therefore it's positive b. Then, if I divide 4 by -2, I get -2. Here are my factors. I can verify. I can verify to make sure that I have my original expression. -2 times 4b squared is -8b cubed. -2 times 3b is -6b. And -2 times -2 is positive 4. These are the factors of -8b cubed minus 6b plus 4. Always look for the greatest common factor first. But in this example, we have an expression where common factor is a number and an algebraic expression. So let's start with the number. I look at 12, 21, and -6. So remember, the greatest common factor is when you can divide each of these expressions by that number and it comes out evenly. So, what I always do is I always start with 2. I can divide 12 by 2. I can divide -6 by 2, but I can't divide 21 by 2. Therefore, 2 is not the greatest common factor. I go to 3. 12 divided by 3, that works, equals 4. 21 divided by 3, that works, equals 7. -6 divided by 3, that works, equals -2. So 3 looks like it works. But let's look at 6 for a minute, -6. I can divide, of course, -6 by -6, which gives to me 1. I can divide 12 by 6, but I can't divide 21 by 6. It doesn't come out evenly. So my greatest common factor would be 3. But I've got to look at my algebra as well. Look at in each of the terms. I have an x in each of the terms. I will have x as a greatest common factor. But now I've got to find the exponent. In order to find the exponent, what do? I look at all of my exponents. Now remember, this is understood that it's 1. I always look at the lowest exponent. The lowest exponent is 1, therefore that will be my GCF because I've got to be able to divide each of those terms by the GCF. So my GCF is 3x. Just like before, once I find the GCF, I place it in front of a set of brackets. Then what do? I divide 3x into each of the terms. I divide 3x into 12x to the fourth. I divide 21x squared by 3x, and I divide that negative 6x by 3x. Why don't you try it at your desk for a minute, and I'll show you on the next slide. So did you get that the other factor is 4x cubed plus 7x minus 2? Let's verify. 12 divided by 3 is 4. X to the fourth divided by x. Remember the laws of exponents. Keep the base, which is x, and I subtract the exponents. It's understood here the exponent is 1. 4 minus 1 is 3. That's why the first term in my second factor is 4x cubed. I go to the next expression, 21, and that's a positive 21. Positive 21 divided by 3 is positive 7x. I keep the base. I subtract the exponents. 2 minus 1 is 1. It's understood that when there's no exponent, the exponent is 1. I'm subtracting. I'm subtracting. 6 divided by 3 is 2, and x divided by x eliminates. My factors are 3x and 4x cubed plus 7x minus 2. These are the factors. I can verify. When I verify, I multiply the GCF by each of the terms inside the bracket. 3x times 4x cubed is 12x to the fourth. 3x times 7x is positive 21x squared, and 3x multiplied by negative 2 is negative 6x. My job is done. I verified. I now ensure that I have the correct factors. And here's a last example. Why don't you try this before I show you the solution? Did you realize that 5 was the only value that is a common factor in all three terms? You can divide 5 into each of those expressions, but there are no algebraic expressions that are common in each of them. They must be common in all three terms. So 5 is our GCF. Did you place your brackets? Did you then divide each of these expressions by the GCF? Did you realize that 25 divided by 5 is 5, and that the n squared cannot be simplified? Did you realize that 15 divided by 5 is 3? And of course, that's a negative 3. And the m cannot be eliminated. And did you realize that 10 divided by 5, and of course you're subtracting, 10 divided by 5 is 2, and n cubed cannot be eliminated. Therefore, our factors are 5 multiplied by 5m squared n squared minus 3m minus 2n cubed. Always verify your greatest common factor first whenever the instructions are to factor. Again, I'm not going to read this, but I hope that these steps will help you. And I hope that this is a suggestion for you for your memory aid.